Hi everyone, my name is Paolo Piccinini, Professor Andrea Prati is my tutor, and Professor Rita Cucchiara is my co-tutor. My PhD is focused on a research project in collaboration with the Marchesini Group from Bologna. The goal of this project is to develop a beam picking system for both cosmetic and pharmaceutical objects. In beam picking application, robots are required to pick up an object from a pile of scattered objects placed in a bin, and usually these applications are designed for a specific object that in most of the case is a mechanical part. Marchesini instead asked for a system able of handling a very different kind of object. And our system must work with semi-transparent object, reflective object, and object wrapped in flow pack. Moreover, the robot must pick up 100 objects per minute, and the object can be very occluded. These few blocks represent the whole system. In the first, the image is simply acquired by the camera. In the second, the image is processed in order to discover the object position and its orientation. In the ghost detection block, the wrong segmentation due to flow pack or reflexes are discarded. And in occlusion detection, the occlusion between two or more objects are computed in order to discover the topmost object. At the end, the list of the objects to be picked up is available. The object localization and pose estimation is the core of this project, and is divided in three parts. In the first, the features are extracted from both the model and the current image, and matched together using the SIFT algorithm. After that, these matched features are clustering by a voting scheme in order to discover the center location of each object, and with the knowledge of the center location, the system is able to define the whole shape of the object. However, when the objects are quite transparent or wrapped in flow pack, the system tends to fail due to the lack of features. In order to avoid this and increase the number of objects detected, we have done two improvements. The first is the multi-model extension, and the second in the split image matching. In the multi-model extension, and model are matched with the current image in order to increase the number of matched features. And in the split image matching, the current image is divided in n part, and each of these sub-images are matched with each of the n models. Sometimes, due to the flow packs and reflexes, the system shows some false segmentation, like the one in the leftmost image. Looking at this image, you can see that this wrong segmentation has an high overlap with a real object, the same direction of the real object, but a score lesser than the real object. So, using these few observations, the rule to discard this false segmentation is straightforward. And in the rightmost image, you can see the result after the ghost detection. The occlusion detection block is needed to answer this question. That is, which is the topmost object? Answer this question is very simple for a human being, but it's not so easy for a vision system. Choosing the topmost object is done in a very simple way. Given the segmentation, the histogram of gradient orientation is computed in an intersection zone, and this is the histogram. After that, the histogram of the gradient orientation is computed considering only the first object, and the same is done for the second object. Comparing the intersection histogram with the other two, the more similar represents the topmost object. So the system is able to choose the green object as the topmost object. This is very important for the strategy to pick up the object from the bin. Finally, this is a simple sample of the working system. This is a classical scene with a spreading object and a couple of occlusion. After the image acquisition, this is the result of the segmentation. As you can see, there are 4 available objects in green and a partially occluded object in orange. For example, the system chooses to pick up these 3 objects, and after a new acquisition and a new segmentation, I have this new segmentation. You can see there are 2 available objects in green, 1 partially occluded, and 1 red object that is an object that cannot be picked up. Looking with more attention at this red object, you can see that this is an error in the ghost detection, but the occlusion detection, choosing it as a non-pickable object, in some way adjusted this error. And this time, the system chose to pick up this object, these 2 objects, and after another segmentation, another acquisition, and another segmentation, the last 2 objects have been found. This is the title of the Italian patent related to this project. A research in European Patent Office confirmed that this patent can be extended as a European patent and will be submitted as soon as possible. Finally, this is 2 pictures from Marchesini facilities. This is the very first prototype. You can see the robot, the conveyor belt, and our platform near it. And the brown thing to cover the cameras in order to avoid some kind of reflexes or highlight. This is the list of my publications. There are 2 international conferences and a couple of submissions in a journal. That's all. Thank you for attention.
Paolo, so no question, because it's great that we have a patent, and we will, it's very important for our school to have a patent. What I want to ask you is if you ask Marchesini to put ICT doctorate school on the on the machine just to promote our school. We can ask as a sponsor. Thank you.